Okay, I'm back, and now we want to discuss why does water boil. Now, I'm sure that you're all familiar with the fact that you can take a pot of water, put it on the stove, turn up the heat, and eventually the water is going to start to boil. So what's happening is changing from a liquid water to gaseous water, which we call steam. And then if you were to reduce the temperature, eventually it would freeze. It would go from liquid water to solid water, which is ice. But we're not concerned with the ice. So we're really just concerned about why does water change state from a liquid to a gas. And one of the reasons is temperature. Okay, so here is our container of water. Okay, and now let's say that this represents a molecule of water that's in there. And let's say it's moving in this direction, and it's moving at a pretty good clip. But here's another molecule of water, and let's say it's going slower. So we'll illustrate that by a smaller arrow. And then let's say that here's another molecule of water over here, and let's say it's going in this direction. So notice that the millions and billions of water molecules, they all have different speeds, and they're all going in different directions, and they're constantly bumping into each other. So that if, let's say that this molecule water bumps into this one, it could change the speed of this molecule, make it go slower, and then maybe this one would speed up. So they're constantly changing speeds and they're changing directions as they're bumping into each other, and it depends on the temperature. So if you recall, we defined the temperature of a substance as being proportional to the kinetic energy of the molecules that makes it up. And if just to remember here, the kinetic energy is equal to 1/2 mv squared. So that the faster a molecule is moving, the more kinetic energy it's going to have. And then when you average all of those kinetic energies of all the molecules of the water, then that's going to be the temperature of the water. So that when you heat up water, so let's put a candle underneath it. When you heat up that water, what's going to happen is the molecules are going to start to move faster. And eventually, they might be going fast enough that one of these molecules might jump out of the water. So it's got enough kinetic energy that it can break free of the water, and it turns into steam. It's now turned into a gas molecule of water up here. Now, what happens though is the atmospheric pressure doesn't like that. So the weight of the Earth's atmosphere, 500 miles of air on top of you, pushing down, acts like a lid. And so the air pressure pushing down will cause some of these water molecules to go back into the water. So if you increase the temperature, then more and more of these molecules are going to be able to resist the air pressure, and they're going to jump up out of the water. Okay, so now what would happen if we reduce the air pressure? So we're going to keep the temperature the same. So we know that we can boil water if we increase the temperature. But now what we're going to do is keep the temperature constant, and we're going to reduce the air pressure. We're going to start to pump the air out of the room so that there's less and less pressure that's acting like a lid, and so that's going to allow more of these molecules to jump up out of the water. So what I want you to do is watch this video, Boiling Water at Room Temperature Science Experiment on YouTube. And so you're going to see that that water in that vase or flask right there is at room temperature. You could take your finger and put it into that water and it's not going to burn you. It's at room temperature. Okay, then what they do is they start to crank the handle and it's going to start to remove the air from the inside of that flask, and eventually you'll notice that the water is going to start to boil. And if you were to take your finger and put it into that boiling water, you'd be okay, because that water is still at room temperature. So the reason why it's boiling is going to be from lack of air pressure. And this is going to be important because on a planet, if you have a planet that has a very, very thin atmosphere, it's not going to have enough air pressure pushing down to keep water in its liquid state. So a small planet is not going to have much of an atmosphere, so therefore if it has any water, that water is going to boil. It's going to turn from a liquid to a gas. And so that's going to explain, for example, why is there not water on the moon? Not enough air pressure to do it. Okay, let's take a break, and when we come back, we're going to talk about the moon.